So hey guys, last time we saw the fundamental principle of addition and multiplication, right? Now let's see it with a little bit different approach, okay? A little bit different way of how to think of the addition and multiplication. So before beginning, we will learn something very ingenious idea. What is functions? Okay. So if I ask you, you are having two sets. Okay. Let's say 1, 2, 3, 4, and 5 are the elements of the first set, and the A, B, C, and D are the elements of a second set. Okay. So what I want you to do to tell me the how many number of functions are possible. Now, to be put it simple, the function is something where each element of this set will be associated with exactly one element of this set. Okay, so what you can do, you can take element 3 from the left set and you may pair it up with the element C. So what this tells, 3 comma C is an pair. Okay, so in order to answer this question, let's see how we can approach it with the multiplicative logic. Okay, so those who knows the answer, yes, it's all right. I understand that these are the fundamentals. So let's see how intuitively you can say. Okay, so I am having the element 1 from the left set. Now how many choices does it have to pair up on the same element with the right set? It is having 4 choices, right? No issues there. Okay, good. Now let's say 1 is been paired up with some element, say B. Now after that, if I want to pair up element 2 with some element, is there any restriction, is there any constraint that it cannot be paired up with B, or it has to paired up with only B? No, not at all. Okay, so we understood that the pairing of a one element does not affect the other element, right? So what does it implies? So it implies that if I want to pair up the second element, which is 2, what I can do, I have given freedom to the first element, it can take any 4 choices. Now corresponding to those 4 choices, I can make another 4 choices for the second element, because 2 can also map with any of the 4 elements. So you are getting this right. 1 can be mapped to A. So corresponding to that, say let's say 1 has mapped to B. Okay, sorry. Now corresponding to that, 2 can be mapped to either A, either B, either C, or either D, right? So you got this. So there were 4 choices if the one had been mapped to B. Now similarly, one could have been mapped to A, or one could have been mapped to C, or one could have been mapped to D. So again there are 4 choices each, right? So what we are doing is that instead of adding these all as in 16 choices, we are just using smart trick here, that we are simply multiplying, because we know corresponding to each and every choice of the first element, we can have 4 choices for the second element. Similarly, corresponding to the combination of first and second elements choices, we can again have 4 choices for the third element, right? Let's say 1 gets mapped to B, 2 gets mapped to C. So given that now 3 can map to either A, B, C, or D. Again it is having 4 choices. So that's why I have written 4 over here, because it doesn't matter where the 1 and 2 were mapped. It's getting mapped independently. Independently is the keyword, guys. Okay. So we understood that 3 can be mapped to anywhere, right? Now given that these 3 are mapped, we need to map the fourth element. Again, corresponding to each of the possible combination of these 3, we are again having 4 choices for adding the fourth element. So again we will be multiplying by 4, right? Now we will extend this. Now each combination of these 4 elements, for each combination of these 4 elements, we can add the next mapping for the 5 in again 4 ways. So we again multiplied it. So are you getting this, why the answer is 4 raised to 5? I will again repeat it once. see, for the first element we were having the four choices, second element also we were having the four choices, but these choices were independent. It doesn't matter what element one gets mapped to, so we were free to do any of the pair up for the second element. So that's why we multiplied, because we are independent, we are not bothered by where the one were mapped. Okay, so again for the third element, fourth element and the fifth element. So I hope you had understood this idea. So let's say the left set had total A elements and the right, okay, I can't use A, sorry, had total M elements and the right side has total N elements. So how many functions will be there? For each of the M, I am having N choices. For the first element, I had N choices. For the corresponding to which for the second element I again had n choices, corresponding to third element I again had n choices, so and so. For the mth element I also had n choices, so it will sum up to n to the power m. Okay, I hope you have got this idea. Now let's go a little bit ahead. Okay, so yeah, drawing mode. Okay, yeah. Okay, so now let's see the principle of addition and multiplication, sorry, and multiplication with respect to sets. Okay, now say uh, a person has let's say as usual nine shirts. Okay, nine shirts and five pants, say. Okay, now if the person wants to go to the beach, or let's say anything, he is going to be half naked. Okay, don't think too much in imagination, just for the example. Okay, so if he wants to go half naked, okay, now he will be having what choices? Either he will choose one of those nine shirts, or he will be choosing one of his five pants. So do you understand that why the answer would be 9 plus 5? Because either he will be choosing one of 9 pants, or he will be choosing one of the 5 pants, right? It's not that he will choose one of the 9 shirts corresponding to which he will choose one of the 5 pants. No, not at all. He just have to choose one thing, either one of the shirts where he is having 9 choices, or either one of the pants where he is having 5 choices. Okay, so if I represent the shirts by set S, okay, uh, yeah, by the set S, and pants by the set P. So what you can tell me? There are total 9 shirts, so cardinality of set S will be 9. There are total 5 pants, so cardinality of P will be 5. So how can I say this answer to this question in terms of sets? I can say that it's equivalent to S union P. Why? Because I will be, this you can read as an or operation. Okay, either I will be wearing one of the 9 shirts or one of the 9 pants. So what this sums up to? S plus P, right? Now I know I am not writing here the intersection term, but for a while let's ignore that. Okay, not that complex it is needed as of now. Now the second question is, how many total outfits I can have? Total outfits. Okay, so total outfits means I am going to wear both shirt and pant, and how many combinations I can have for the shirt and the pants. Okay, now the basic logic which we saw in the last lecture, how can I tell this? I can say I am going to wear shirt, corresponding to which I am going to wear a pant, and because both of them are independent, I can use the multiplication sign, right? Now I am having 9 choices for the shirts, and corresponding to each choice I can make for the 5 choices for the pants. So what answer do I get? 45. Now I ask you, how will you represent this in terms of sets? Okay, if you don't know, still try to think, pause the video, give a little thought about it. Okay, so I hope you had paused the video. So let's continue. Now there is a something called as you might heard this, Cartesian product. Okay guys, Cartesian product is how we relate the multiplication principle to sets. So see, when I write S cross P, what will it give me? It will give me x comma y pairs such that x will belong to set S and y will belong to set P. Okay, so what does this represent? X means the choice of shirt and Y means the choice of pant. And as this is set, we already know that there can't be duplicates. Like this can't happen that you have wore the shirt S1 and pant P4. This is your one of the pair, and this has been again repeated S1 and P4 in the set. No, it's not possible because set won't allow the duplicates. Now, intuitively, how you can think? So I can say that shirt S1 has mapped to pant P1. Again, shirt S2 has mapped to pant P2. So and so, shirt S1. Sorry, my mistake over there. S1 has mapped to pant P5. Okay. Again, you will be having the shirt 2 for which you will repeat the same story. P1 and up to S2 with P5. Okay, so you understood the logic here. Here I were talking about the shirt S1, whereas I were giving the freedom to pant. Okay, here I were talking about the shirt 2 and I again gave freedom to pant. Similar story would go for S9, right? So how many pairs are there? If you ask me how many pairs are there, so just give me a second. Yeah, so what can I say? Right, again, look at here. uh, I would say I had 9 shirts. Okay, the cardinality of S were 9 and the cardinality of pants were 5. So what I told, I had 5 choices for the shirt 1, again 5 for the shirt 2, and so again 5 choices for shirt 9. So what this tells me, if I do addition for all of them, the answer would be 9 into 5, and that's what our multiplication principle is. And if you see this, what you can say, this is equals to cardinality of P into cardinality of S. Okay, right? So this is in terms of set. So what you can say, for the multiplicative principle, cardinality of S cross P is equals to cardinality of S into cardinality of P, because when I am forming the pair, regarding for each one choice of S, I am having freedom to choose any one of the choices from the P. And there are how many total choices? There are total P choices. Okay, for one instance I had total cardinality of P choices, and how many instances I have total S instances, cardinality of S. So I had made the pairs, right? For each of them I had choose the pant. Now I understand that this might seem a quite easy thing, but believe me guys, give it some thought after watching the video. Please try to make up your own intuitions. Like when some problem arrives, it's really important that when you are going to perform multiplication and when you are going to perform the addition. Okay, so it is really the most important thing, and believe me, I will tell you very intuitively the next combinatories and permutation. Okay, so what we need to do, just try to understand what the things want to say. Whenever you are taking the multiplication, just understand that you are talking about the freedom. Here in this example, it didn't matter what choice we had for the one, so we independently choose one of the possible choice for the second element, right? So how did we convey this? We, for that purpose, we use multiplication, right? Because these were independent and related, because it in the final appearance it mattered to me which element had been mapped to which other element, right? So it were important for me, so that I can tell you how many total number of functions are there, right? So that's why we just perform the multiplication. Okay, and similar we have seen for the addition, right? How when we perform the addition, right? When we are having or operation, like either I will going to do this or I will going to do this. So this or operation is conveyed through the union operation. In the next time we will be talking in much depth about the other further combinatories things. Okay, so I will end over here. Take care of your time and take care of yourself. Thank you guys.